All right, welcome. In this explainer, we are going to master the essential Pandas workflow. This is the step-by-step process that pretty much every data analyst uses to go from just a raw file to a real, actual insight. So let's get started. You know that feeling, right? You get a new data set. Could be student records, sales data, whatever. And that first step can feel a little paralyzing. What's the very first thing you should type to even begin to understand what you're working with? Well, that's exactly the question we're answering today. So, here's our game plan. We're going to start with the most critical step, loading the data the right way. Then, we'll run a quick diagnostic checklist. Think of it as a health check for your data. From there, we'll learn how to isolate the exact data we need before, finally, putting it all together to answer a real question. You know, everything in data analysis starts right here. Before you can find those amazing insights or build cool models, you have to get your data into a Pandas DataFrame. And trust me, getting this first step right saves you from a whole cascade of problems down the line. Our main tool for this is pd.read_CSV. It's incredibly powerful. It takes a file, in our case students.csv, and turns it into a structured data frame. But its real power isn't just loading the file. It's in all the optional parameters that let you control exactly how that data gets loaded. Now, these 4 parameters right here, they're like your secret weapons for clean, efficient data loading. They give you control over what data comes in and how Pandas understands it from the very beginning, which will save you massive headaches later on. First up, use calls. Imagine you have a CSV with 100 columns, but you only need 5. Why would you load all of them? Using use calls tells Pandas to only parse and load the specific columns you tell it to. For really large datasets, this is an absolute game changer for performance and memory. Next is NA values. Let's be honest, real-world data is messy. Missing values might show up as empty strings, or the text NA, or null, or something else entirely. This parameter lets you give Pandas a list of all the different things that should be treated as proper missing data, what Pandas calls NaN. In our student data, one student, Nikhil, has a missing score, and this ensures it's handled correctly right from the get-go. Ooh, this parameter is a huge one. By default, dates in a CSV file are just seen as text, as simple strings, but parse dates is magical. It converts them into powerful datetime objects, which immediately unlocks the ability to do things like filter by month, calculate time differences, or build time series plots. It's so useful. So the data is loaded. What now? Well, the next thing you do is run a quick diagnostic. This is a routine you should get into the habit of performing on every single new dataset to get a high-level summary of what you're dealing with. Your first command should almost always be df.head. This just shows you the first 5 rows of your data. It's not for deep analysis or anything, it's just a sanity check. Did the columns load correctly? Do the values look kinda like what I expected? It's that first visual confirmation that, okay, we're on the right track. Next up, df.shape. Now, this isn't a function, it's an attribute, so you don't need the parentheses at the end. It instantly tells you the dimensions of your data. It gives you a tuple with the number of rows and the number of columns. For our student data, that's 5 rows and 5 columns. It's the absolute quickest way to understand the scale of your data set. And now for the powerhouse, df.info. This gives you an amazing technical summary. For every column, you see its name, the count of values that are not missing, and its data type, or D-type. This is exactly where you'd confirm that any values worked and correctly identified Nikhil's missing score. And you'd also see that parse dates successfully converted our join date column from a generic object into a proper datetime64 type. Now, for any columns that have categories, like the branch column in our student data, value counts is indispensable. It quickly counts up how many times each unique value appears. In just one line, we can see we have 3 students in the data science branch and 2 in the AI branch. It's a fundamental tool for understanding how your data is distributed. Okay, so by now we have a really good overview of our data set. The next logical step is to learn how to isolate specific pieces of it, to really zoom in on the columns and rows that matter for our analysis. The type of brackets you use here is absolutely critical. Using single square brackets will give you back a Pandas series, which is basically a 1D object. But using double square brackets will always give you back a data frame, a 2D table. Understanding this difference is so important, especially when you start chaining multiple commands together. When it comes to selecting rows or even rows and columns together, there are 2 main tools, lock and iLock.
This simple little phrase is the key to remembering how they're different. Lock is for labels. iLock is for integer position. Let's see what that really means.
With lock, you use the explicit names or labels. So df.lock0:name is asking for the data at the row that's labeled 0 and the column that's labeled name. With iLock, you're using the integer position. df.ilock0:0 is asking for the data in the very first row and the very first column, no matter what their names are. It's kind of like the difference between asking for a book by its title versus just asking for the first book on the shelf.
Okay, so selection lets us grab specific pieces by name or by position. Filtering takes that a step further. This is how we start asking really complex questions of our data, like which students scored above 90, or which AI students are from Kochi. The magic behind filtering is something called boolean indexing. It might sound a bit technical, but it's really a simple three-step process. First, you write a condition that results in either true or false for each row. Second, Pandas gives you back a whole series of just true and false values. And third, you just stick that Boolean series inside the selection brackets of your data frame, and like magic, Pandas will only show you the rows where the value is true.
A lot of the time, you'll need to combine different criteria. You can do this using the ampersand for and the pipe symbol for or. Now, the single most important rule here, and it's a super common mistake for beginners, is that each individual condition must be wrapped in its own set of parentheses. Don't forget that. Pandas also gives us some really helpful shortcuts for common filtering jobs. So instead of writing a bunch of OR conditions, you can just use .isin to check if a value exists within a list. And to safely get rid of rows with missing data, .notna is a super clean way to select only the rows that have valid data in a specific column. Okay, we've loaded, we've explored, and we've learned how to select and filter. Now it is time to combine all of these skills to answer a specific question. Let's find our top-performing students from the data science branch. Just look at this single, elegant line of code. The first part is our filter. It finds all the rows where the branch is DS and the score is 90 or above. That operation gives us back a new, smaller data frame. Then, right away, we chain on the second part, which selects just the name and score columns from that result. This is the whole essence of Pandas, combining simple, powerful steps to get the precise answer you need. So, we've just walked through the fundamental workflow of data analysis in Pandas. From loading a file all the way to answering a targeted question, these are the core building blocks you'll use to explore any dataset. You now have the keys to the process. The only question left is, what stories are waiting for you to unlock in your own data?